Welcome, ladies and gentlemen, from my side to my talk on the lead factory, the pilot factory of the JKU. I have divided my talk into three sections. In the first section, I want to talk what the LIT factory is actually about. In the second part, I want to give some information on the research that is performed in the LIT factory. With the final part, I want to give some insight into existing projects in the LIT factory and possibility of cooperations with us. So let's start with the first topic. What is the LIT factory? The LIT factory basically is a smart research factory that deals with polymer product development, polymer processing, and the re- and upcycling of thermoplastic polymeric materials. The LIT factory is funded by the Federal Ministry of Climatic Action, Environment, Energy, Mobility, Innovation, and Technology, and the FFG, the Research Promotion Agency. LIT factory is also supported by 25 corporate business partners that covers the whole value chain in polymer technologies. That means we have, for example, material suppliers like Borealis and Covestro, machinery suppliers like Engle, Riemer and Leistritz, tool makers like Heidelmeier, and polymer processors like FACC and Kreiner. And beside of that, we also have companies that are experts in digitalization, automation, and software development, like, for example, Siemens, Dataformers, and Axavia. Moreover, I want to thank the state government of Austria and the city of Linz for their generous support for the LIT factory. So processes in the LIT factory covers the whole value chain in polymer technologies, including circular economy. And a huge benefit of this infrastructure is that we can perform research and development not only on single process elements, as this is more or less common at universities, but we can do this from an integrative perspective along the whole processes and value chain. And this in turn enables us to perform digitalization and digital transformation along this process chain. For example, to set up digital process twins or to reduce data barriers between stakeholders. In the future, the LIT factory should serve as an open platform to demonstrate and teach potential technologies in polymer processing. So what are the main research interests of the founding partners and institutions of the LIT factory? Focus one lies on the production of fiber-reinforced thermoplastic composites. Such composite structures are typically used in automotive aerospace sector, especially with respect to e-mobility, where a reduced weight is transferred into an increased energy efficiency during the operation. However, such structures are applicable for various other fields of applications, for example, in automation systems or for EGAL exoskeletons for humanitarian aids. From the sustainability point of view, the benefit of thermoplastic composites, and that's why thermoplastic is written here in bold letters, is the recyclability compared to duroplastic components and the possible high grade of production automation. The second focus in the LIT factory is the recycling of thermoplastic waste flows. Actually, we prefer the terminus reusable material instead of waste. Also, this is not very obvious when we are faced with a lovely countryside polluted by plastics in everyday media. But I think exactly for this reason, it is of tremendous importance for us all to collect as much plastic goods as possible to perform either mechanical or a chemical recycling process where this is suitable, or to transfer the materials to thermic utilization where this is not possible. In the LIT factory, we want to focus on the mechanical recycling process and develop adjustable processes to achieve a high quality output material. Last but not least, the third focus lies on the digitalization and digital transformation along the value chain in polymer processing. And therefore, we build up an infrastructure to reduce data barriers between the stakeholders, to analyze and visualize process data, and to develop, set up, and compute digital twins for the processing equipment. So what kind of research is performed in the LIT factory? For the production of the fiber-reinforced thermoplastic composites, one major field is the product design for tailored fiber-reinforced parts to achieve the specific mechanical properties with a minimum of reinforcement and thus with a minimum of material on the one hand, and to ensure the recyclability of the products at the end of their product lifetime. Next, we perform process optimization for extrusion and unidirectional fiber reinforced tapes, as these or such tapes serve as the basic component for our composite structures. And finally, we investigate the process chain for the composite production to optimize these processes and to develop assistant systems for simplified process setups. For the recycling of thermoplastic waste flows, it is of utmost importance to separate the waste stream into fractions of the same polymer grades, as well as to grind, wash, and characterize them to get a well-defined material input stream for the subsequent mechanical recycling process. And for this, we want to investigate new methods for inline characterization of the washing process. In the first step, we want to do this clearly on a laboratory scale. For the recycling process itself, methods for process optimization and inline quality measurements should be developed. And the final goal is to characterize the output stream with respect to the product quality, and thus to define specifications as well as certificates for the hopefully high quality recycled polymeric materials. For the development of digital twins, we try to use hybrid modeling attempts where we use solutions from numerical simulations, possibly combined with process measurement data to set up so-called heuristic process models that we can finally use to predict complex processes with quite a low computational effort. Make this a little bit more clear, I want to show an example of such a hybrid modeling approach that was used to calculate the pressure throughput characteristics of a single screw extruder. In general, is that the solution of such processes require numerical methods with the drawback of a quite high computational time. However, by using a hybrid modeling approach, it was possible to find a closed analytic equation for the problem to predict the pressure throughput behavior for different process settings. And in the diagrams, this is shown. Here we compare the experimental results to the predicted throughput of the digital twin. The marks show here the experimental results, while the solid lines display the predictions of the simulation. And I think we all agree that we have a very good correlation here between the digital twin and the experimental results. Another example on this can, for example, be the utilization of artificial neural networks for process optimization on the one hand, or for the development of assistant systems on the other hand. And what is shown here, that we trained a neural network to predict machine parameters based on pictures of the surface of foam injection molded parts. And it's like that the surface quality of these parts changes with the process settings. And the trained neural network was able to detect by a picture of the surface with which process parameters the part was processed, and also gives an advice to the operator how he should change the process parameters to improve the product quality. So this brings me to the last part of my talk, which deals with existing projects and collaborations in the LIT factory. First, research projects are carried out together with the newly founded K1 Competence Center CHASE, which stands for Chemical System Engineering. And the center is a cooperation of the JKU Linz and the Technical University of Vienna, with a consortium of 24 corporate business partners and 14 scientific partners. In general, the center is divided into three research areas: the process digitalization, process intensification, and circular process streams. And the LIT factory takes part here in all the areas and supports the center with its infrastructure and with its competence in its scientific competence in polymer processing. Besides such typically large research projects, it's also possible to do quite simple cooperations with us, like it's shown here, for example, for a cooperation with the LIT Robot Psychology Lab of Professor Martina Mara. And here the colleagues compared various learning methods on the machinery of the LIT factory. More specifically, a user is guided through the startup process of a machinery, either by only an instruction sheet, only audio support, or a combined system of video classes, eye tracking, and audio support. And the machinery in the factory provides here different types of interfacing, like screens, push buttons, or also the interaction of multiple machine components. Another cooperation that's, let's say, at the moment in the startup phase is a cooperation with Silicon Austria Labs and the Institute of Communication Engineering and RF Systems. And here the goal is to build up a 5G test bed in the LIT factory, where in the future, for example, machine-to-machine communication with mobile networks should be investigated, also for safety-relevant topics, or, for example, also position tracking within buildings. This brings me to the final slide of my presentation, and with this slide, I want to show possible links for further cooperations with the JKU. For example, in the field of digital transformation and artificial intelligence, we are looking for partners that can support us with their scientific competence in these fields. Or another idea may be the research of security and safety topics in an industrial-like environment. But not only from the technical point of view, also we have here some research field on this slide that are mentioned as accompanying research. And also in this type of topics, we are open for collaboration. So if there are any ideas don't hesitate to get in contact with us, because we think the LIT factory is a pretty cool infrastructure that we can hopefully share with other researchers at the JKU. So this brings me to the end of my talk, and I want to thank you for your attention.